The distributive property. The distributive property is just a way to multiply. I use it. You could use it for every single question if you wanted to. We typically only use it when we have a monomial times a polynomial. Okay, so that means a monomial is something like this guy right here. 2, right? That'd be a monomial. And then there's brackets, which means multiply. And then there's some sort of polynomial in here. Right? That's what it is. The distributive property goes like this. You take the monomial and you bring it into the bracket. So we're going to take this 2x and we distribute it to each term in the brackets. I do it like a little rainbow with little lines. Okay? When you're distributing it, every time you bring it to a term, you multiply it by that term. When you're multiplying, numbers go with numbers, letters go with letters. So when we multiply the first time, let's just look at it here, the 2 multiplies to the x. That would become 2x. Right? There was a 1, invisible 1 in front of the x. 2 times 1 would become 2. The x would stay as an x. We then distribute it in to the positive 1. 2 times 1 would be positive 2. We multiply the 2 in using the distributive property. It becomes 2x plus 2. Awesome. We're going to look at a bunch of examples together. So if the first one didn't click, maybe the next 4 will. If you look at the second question, that is a monomial times a polynomial. The monomial being this thing right here, and there's no additions or subtractions. Brackets means multiply, right? Because there's nothing in between the monomial and the brackets, so that means multiply. And then you have a polynomial on the inside, x plus 3. To multiply a monomial, no, I was like marbles on my mouth. To multiply a monomial into the brackets, we use the distributive property. It goes to the first thing. X times x. When you're multiplying the bases, you add the exponents, right? Like from last unit. So this is x to the 1 times x to the 1 becomes x to the 2. Add the exponents. Then the monomial distributes in to the second term, which is a 3. X times 3 would become positive 3x. You'll notice in both cases, if I multiply a monomial into a binomial, I get a binomial answer. And that'll happen every time when you distribute a monomial into the brackets. You'll end up with the same number of terms that were inside the brackets. Look at the third one. I'm going to take this monomial of 2x. I'm going to multiply it into the brackets. 2x times x. So numbers with numbers, letters with letters. The 2 multiplies by the coefficient of an invisible 1 to become 2 still. The x multiplies by the x to become x squared. We then distribute it to the second thing in the brackets, which is a negative 2. Numbers with numbers, letters with letters. So negative 2 times 2 would be negative 4. And the x would still just be an x. So it's 2x squared minus 4x. We'll do 2 more that are a little different. This one is a negative 3. The negative I attach to the 3, I feel that makes it easier. So I say negative 3 multiplies into the brackets. We distribute it to the first guy. Negative 3 times x would become negative 3x. Negative 3 into the brackets to the negative 1 becomes positive 3. Right? Negative 3 times negative 1 is positive 3. The very last guy is a little different. The reason why it's a little different is the monomial is in the second thing listed, right? All the other examples, the monomial was in the front. In this case, the monomial is in the back. And because there's nothing separating the monomial and the other polynomial, then it's still multiplication. But if there had been like a plus sign in between or something like that, that wouldn't be multiplying. So this wouldn't work. But because there's nothing between the brackets, that means multiply. We can distribute. We'll just do it backwards. So we're going to distribute this to the first term. 2x times x would become 2x squared. 2x times negative 1 would become negative 2x. Awesome. That's the distributive property. Not that bad, hey? I like to think of it when you're distributing in numbers multiply with the numbers, letters multiply with the letters. Don't mix that up. You could try these examples right here. Some of them are a little bit bigger, right? But give them all a shot. So see if you can distribute these 4 examples. Perfect. If we multiply them in, I know some of you guys might not be done, and that's okay, but we just kind of limited time. We take this 4, we distribute it by multiplying it in. 4 times 3x, numbers with numbers. 4 times 3 would be 12. X would just be x, because there was no other letters. We then also distribute it to the 1, it becomes plus 4. Right? 4 times 1 is 4. Some people would put 5 there, right? And you're just mixing up what you're doing. It's not 4 plus 1, it's 4 times 1. Awesome, if you look at B, we're going to do the same thing, it's just more of it. So we have negative 5 as the monomial. We distribute it in, it becomes negative 10x squared. And numbers with numbers, so negative 5 times 2. We then distribute it again to the plus x. Numbers with numbers, letters with letters. This would become negative 5x. And the last one, negative 5 times negative 6 becomes positive 30. Fantastic. C is one of those backwards ones. So you take the x squared, you multiply it in to become x to the power of 5. Remember, it's the power of 5 because when you multiply bases, you add the exponents. So x cubed times x squared is x to 3 plus 2, which is x to the power of 5. If you multiply it into the second thing, you get negative 2x squared. The very last example, we're going to multiply the negative 3x in to the 7x, become negative 21x squared. Okay, so negative 3 times negative 7, or positive 7 is negative 21. X times x is x squared. The tricky one that we haven't seen before is the second one. Numbers with numbers. So negative 3 times negative 2 would become positive 6. So we have a plus 6. And then the letters with the letters is a little tricky. This is the first time we've had letters that aren't the same letter. And we have x times y. Remember when we did this in Unit 1, we said that you can't combine the exponents if the letters are different. So the way you would write x times y would just be xy. That's it. Same thing's going to happen when we do our final distribution. To the z, it will become negative 3xz. Not bad, eh? All right, typically, when we do multiplication, when we're done the multiplication, there's like terms that could be collected, right? Like what we did earlier this morning. So these will be examples of that. When you expand and simplify means collect like terms after you expand. Expand means multiply, right? So if you look at this question, it means multiply, then collect like terms. Awesome. Looking at this one, you need to recognize where the multiplication is. The multiplication is the monomial, the negative 4, that are attached to the bracket. The 6 is its own term. It's on its own. All right, so this negative 4 multiplies into the bracket. We have negative 8 over 32x. Then it multiplies to the plus 1 to become negative 4. This 6 out front is still just out front. It doesn't multiply into the brackets because it was not beside the brackets. It was separated with a minus sign. Now that we've multiplied the monomial into the brackets, we can do any like terms that we have here, any additions or subtractions. In that case, we have 6 and minus 4 are like terms because they're both constants. There's no letters attached. 6 minus 4 is 2, and then negative 32x is still negative 32x. Fantastic. So when you're expanding and simplifying, you're following BEDMAS rules, right? Multiplication first, addition and subtraction next. If you look at B, we have a couple things that need to be multiplied here. So you have the first monomial times the first binomial. Then you have another monomial times another binomial. When you do the multiplications, all the brackets will be gone because you've used the brackets, right? You've done the multiplication. Then you collect your like terms. So when I do my multiplication, 4 times 2 would become 8x. 4 times negative 3 would become negative 12. When I multiply the yellow guy, negative 2 times x becomes negative 2x. Negative 2 times negative 6 becomes positive 12. So the first monomial into the first binomial created the red. The second monomial into the second binomial created the yellow. You then have some like terms. The x's can go together and the constants can go together. So in our case, 8x minus 2x is 6x. Negative 12 plus 12 is 0. Right? You could put plus 0 if you wanted, but it wouldn't make a difference, right? So I just not put anything. Yeah.
Why wouldn't it be x squared?
Good question. So this is collecting like terms. So try to think of it as you have 8 of something, like mine is always cookies. You have 8 cookies minus 2 cookies. You would have 6 cookies. You wouldn't have 6 cookies squared, right? Like that would change what you're actually adding and subtracting. We only change the exponent if we're multiplying things together. This is adding and subtracting. Awesome. Okay, next one. Little tricky, so I'll do the first one with you because that's a little easier. Just gonna put a line down here so it separates nicely. We're gonna multiply the 5x into the brackets, just so we can see what that looks like. When we do that, we get 15x to the power of 3 minus 35x squared plus 5x. That's the first monomial with the first set of brackets. All right, there's a second monomial there times another set of brackets. So if you look at this second set of brackets, this minus sign is an invisible negative 1. If you have brackets, you need to use those brackets by multiplying the 1 into the brackets. In our case, though, it's not just a 1, it's a negative 1. So make sure that the negative 1 is going into the brackets and changing the symbols. Negative 1 times 4x would become negative 4x. Negative 1 times 3x squared becomes negative 3x squared. You may have had teachers in the past who just always told you if you have a negative sign outside the brackets, you turn it positive and you change all the symbols. And like that's a trick I know that gets used often. It's a good trick. This is the reason behind it. All right? You have a negative 1 there. It's a monomial into a polynomial. You look at that, you should have some like terms there. In our case, we have x squares. I should use blue so it sticks out. We have x squares that can be combined, x's that can be combined, and then the 15x cubes can't go with it. When we're combining our like terms, we're just doing coefficients, right? So negative 35 minus 3 would be negative 38x squared. 5x minus 4x would be plus 1x. I'm not going to put the 1 in front of it, but you could. And that would be my final answer. Awesome. Is this question here? We got time for it. It's just a little bit of a challenge question. So it's finding areas of things. It says determine a simplified expression for the area of the given shape by adding the areas of two rectangles, subtracting the area of two rectangles. We will do, it's the same rectangle both times. That's nice. So if you look at that, that's an area question. We don't have any, this isn't a rectangle. There's a weird shape, right? And there's no magical formula for weird shapes, right? Like you never learned, hey, what's the area of an awkward looking L? Right? There's no formula for that. The only thing you ever learned was area of rectangles, areas of squares, maybe areas of triangles or spheres or something crazy like that. Our biggest thing that we use in this class is area of rectangles or area of squares, which is length times width. Okay? When you look at an awkward shape like this, you need to try to cut it up into shapes you actually can multiply the length and the width by. Right? Here's how I would cut this one up. I would look at this as two rectangles. And if I cut it right here, I create this rectangle, and I create this rectangle. And if I wanted to find the area of this entire shape, I could just find the area of the red and add it to the area of the yellow, whatever color. Okay? That makes sense. And those are two simple length times width equations. We'll start with the red one. Okay, so if we look at the red rectangle, my length is 2x, my width is 3x plus 2. Length times width is what we're looking for. We would write that as 2x bracket 3x plus 2. That's length times width. Agreed? Awesome. We have a monomial times a polynomial. So what should we do? We should distribute the monomial. Numbers with numbers, letters with letters. 2x times 3x becomes 6x squared. 2x times 2 would be positive 4x. That is the area of the red rectangle. Awesome. Now we got to figure out the area of the yellow one, which is a little bit harder. The reason it's a little bit harder is x plus 5 is my width. But my length is not 4x. 4x is the distance from here to here. We want this distance right there. To figure out this distance, you have to take 4x and subtract whatever this part on the top is that we didn't want. In our case, it would be 4x minus 2x, because that's this distance from here to here. 2x. That means this guy is 4x minus 2x, which equals 2x. It's a little tricky when you get these questions because you got to chop it up and then find the new side lengths for one of your rectangles. If we do the area of the yellow guy, that means we have 2x times x plus 5. We distribute it in, we get positive 2x squared plus, actually, you know what, I don't know if that positive there. We get 2x squared plus 10x. That's the area of the yellow guy. 2x squared plus 10x. My final step is I have figured out the area of the red, right here, area of the yellow, right there. If I want the area of the entire thing, then I should add my two polynomial answers together. Because I want to add them to get the total area. Looking at this, I have x squared with x squares to become 8x squares. I have x's with x's to become positive 14x. That's a 4. The answer would be 8x squared plus 14x. Fantastic. There's an entire assignment there for you to work on. Tomorrow we're going to continue on with